In example 2, we're going to simplify by factoring, another option that you have as you go through these problems. We have sine squared x times cosine x minus sine of pi over 2 minus x. Anytime you have this type of thing within your function, make it easier on yourself and use the cofunction identity to get rid of it. So the sine of pi over 2 minus x is the same as the cosine of x if you look at the box on the front. So we have sine squared x cosine of x minus cosine of x. And what happens here is that we have a cosine in this term and we have a cosine in this term, which means we can factor out a cosine from each one of these. Remember, terms are separated by subtraction or addition signs. And so we have a cosine in both, which we can now take out in front. So we're going to factor that cosine out. And what we're left with in this first term, if we take out the cosine, divide it, we're left with sine squared x. And if we take the cosine out here, again, we're dividing it when we factor it out. Cosine divided by cosine leaves us with just a 1. And then from here, we can go ahead and say, hey, you know what? I see that I have that squared term again and that 1. Can I get something with my Pythagorean identities? So let's take a look at that Pythagorean identity one more time. Sine squared theta, or in terms of, we're using x this time, so let's use x. Sine squared x plus cosine squared x is equal to 1. And what I want is I want sine squared x minus 1. So I want to leave my sine squared where it's at, and I need to subtract 1. So I'm going to subtract that 1 and bring it over to the other side. And when I do that, I have sine squared x minus 1 plus cosine squared x equal to 0. And I only want the sine squared x and the minus 1 on this side, which means I want to get rid of this cosine squared, and I want to move it to the other side. Since it's positive, I'm going to subtract it. So I have sine squared x minus 1 equal to negative cosine squared x. And that's what I'm going to replace. It's a negative cosine squared x that's going to go inside for this. So I can now come back to my work and say cosine x times negative cosine squared x. And then I can multiply these together. Cosine x times negative cosine squared is just negative cosine to the third x. Next, I'd like you to do the try this. Again, try as much as you can first. Unpause it, and then maybe look at one step at a time. If you did the try this correctly, your first step, what I would have done is I would have changed this cosecant of pi over 2 minus x to a secant x. So we get negative secant x minus tangent squared x times secant of x. And then again, looking at the two different terms that we have, here's my first term, here's my second term. What's common to both of these terms is a secant of x. So I'm going to take that secant of x out in front. So I'm going to factor out a secant of x. And what I'm left with here is if I divide negative secant by secant, I get negative 1. And then if I take secant out of here, I'm left with a minus tangent squared x. And then what I should recognize is that I have something squared and I have a 1 that's subtracting it. Let's take a look at my Pythagorean identity with the tangent. So that is tangent squared x plus 1 equal to secant squared. So basically what I want, instead of tangent squared plus 1, I want negative 1 minus tangent. Well, in order to do that, all I have to do is subtract these two and move them over to this side, which means I'm going to subtract the secant squared and move it over to this side. Another thing you can think about is if I need both of these negative and they're on the same side, if I multiply this whole side by negative 1, as long as I do the same thing to the other side, I haven't changed that. So negative tangent squared x minus 1 is equal to negative secant squared x, which is what I have inside here. So if I go ahead and replace, I get secant x times negative secant squared x. And then if I multiply those together, I get negative secant to the third x, which is correct. Now, like I was saying before, there's not always one correct way. So maybe instead of taking out a positive secant x, maybe you took out a negative secant x. And let me just show you that that's fine too. So to this step, if you take out a negative secant of x, you would be left with positive 1 plus tangent squared x. And now what you have is you have the identity as it is without having to maneuver it at all. And you know tangent squared x plus 1 is secant squared x. So from here you could say negative secant of x times positive secant squared x, leaving you again with the same answer of negative secant to the third x. If you have questions, let me know.